Does the equation define y as a function of x? All right, so in example A, let's go ahead and solve this equation for y to see if y can be represented as a function of x. Well, I'll subtract x from both sides of the equation here, right? And that'll end up giving me y squared is equal to 2 minus x, right? After we subtract off the x on the left, it disappears, and you get 2 minus x on the right. And then from there, y squared being equal to 2 minus x will lead us to say that y is equal to plus or minus the square root of 2 minus x, right? Because we take the square root of both sides to remove the square on the y. Now you can see that for every x you plug in here, you're going to get 2 answers out, right? So for example, if I let x be equal to 0, then for y, I end up with the answer plus or minus the square root of 2. And this means there are 2 answers for the one x value, and that's not allowed in a function. So basically in A, we would say it's not a function. You cannot have a function where a single x value produces 2 different y values. All right, let's take a look at example B then. For example B, it's already set up as y equals, and we have then 3x minus 1 over x plus 2. Well, you can tell that for every x value I plug in, I should get exactly one y value out, right? So for example, if I let x be equal to 0, just for a single case, we would have 3 times 0 minus 1 over 0 plus 2. Now, that will cancel out, and you'll end up with negative 1 over 2. And of course, it's just one y value that results. And this is going to be true throughout the domain of the function here. No matter what value you plug in for x, in other words, you're going to end up getting just one and only one y value out. All right, so let's look at example C then next. All right, so you can see from this equation that when you enter a single x value into the equation, you end up with just one y value on the outside of the equation. You don't get something like this that we got in example A, where we have that plus and minus, right? 2 different y values for every x value you enter. That's not what happens here in this equation. So analytically, it appears that C is indeed a function. Now, the fact that it's a function can be also seen graphically, not just analytically. So if I were to graph this function, and for now, you can just take my word for it that this is the proper graph of the function. Basically, the function would look something like this. This graph, which we'll learn how to graph later on in this chapter, passes something called the vertical line test. For the vertical line test, you actually run vertical lines through the graph, and you look to see if those vertical lines intersect the graph in more than one place. If they intersect the graph in more than one place, it means the graph is a graph of an equation that is not a function. But in this particular case, you can see that no line could possibly intersect this graph in 2 places. And as a result, the graph is the graph of a function. And since it's the graph of the equation above, it means example C is also a function.